Hey there, science fans. Bill Nye here. Today we're diving into something super cool in the world of making things. Mechanical engineering, to be precise. We're talking about surface finish. Now, what in the world is that? Imagine you've just built an awesome robot part. You look at it. It might look smooth, or it might look a bit bumpy. That look and feel of the surface, that's what we call surface finish. It's all about the texture of a surface after it's been shaped by a machine. Think of it like the skin of an apple. Some are super smooth, others a little waxy, or even a bit rough. It's a crucial detail engineers really care about. We mainly look at three key characteristics: roughness, waviness, and lay. Roughness is like microscopic mountain ranges on your part. Waviness is like gentle hills over a longer stretch. Lay shows the direction of the dominant surface pattern. Understanding these gives engineers a complete picture of the surface. All right, let's zoom in. We talked about roughness as one of the main parts of surface finish. It's like the smallest, most detailed texture on a surface. These are the tiny, high-frequency imperfections left by the machining process. Think about cutting a piece of wood with a saw. The saw teeth leave little marks, right? It's similar in machining metals or plastics. The cutting tool, the speed of the cut, the material itself, all these things create these microscopic peaks and valleys. So, how do we talk about roughness in a scientific way? We use special parameters to measure it. One of the most common is RA, which stands for roughness average. RA is the average distance of all those points on the surface profile from that center line. There's also RQ, more sensitive to occasional high peaks or deep valleys. And RZ, measuring the average distance between the highest peak and lowest valley. Different industries might prefer one parameter over another. Understanding what causes roughness is key to controlling it. Let's talk about how different machining processes affect surface roughness. Turning on a lathe can give a range of finishes. Fine turning can get you down to 0.8 micrometers. Milling uses a rotating cutter. Fine milling achieves surfaces with RA values from 0.8 micrometers. Grinding produces incredibly smooth surfaces. Typical RA values for grinding range from 0.1 micrometers. Superfinishing processes like honing achieve RA values of 0.05 micrometers. Section 4. Blueprints, bumps, and performance. Why surface finish is a big deal. Engineers use special symbols on engineering drawings to specify surface finish requirements. These symbols communicate all the surface finish requirements. Surface finish has a massive impact on how parts perform in the real world. Consider wear resistance. A rough surface will wear out much faster. A smoother surface generally means less friction and longer life for the parts. For sealing, a smoother surface is crucial for creating effective seals. Surface finish can affect fatigue life. How long a part can withstand repeated loads before it breaks. It also affects fit. When parts need to be assembled with precision, the surface finish determines how they will go together and stay together. Too rough, and they might not fit or could get damaged. Too smooth, and a press fit might not hold as well. Measuring the micro mountains and key takeaways for future engineers. We need special instruments to check surface finish. One common tool is a profilometer, a stylus-based instrument. It has a fine diamond stylus that moves across the surface. The stylus movement converts into an electrical signal to calculate RA, RZ, and other parameters. Optical methods like interferometry create detailed 3D maps. Comparison methods involve visually and tactilely comparing surfaces to standards. Surface finish describes the texture of a machined surface. Roughness is caused by machining and measured using parameters like RA and RZ. Different processes produce different levels of roughness. Surface finish impacts part function, affecting wear, sealing, and fit. Remember, a shiny part involves microscopic science. Keep exploring, questioning, and building. Science rules.